Good evening, everyone. Hope I'm audible. Am I? All right. So I'm live now. Is my screen visible? And am I audible to everyone? Good evening, Avi. Good evening, Arithro. Yes. Yeah, I think I'm audible, right? Okay, perfect. Hey, Christian. Okay. So, AP, GP, you all know the basic formulae for AP, what we use. Nth term is always A plus N minus 1 times D, where A is the first term, all right? N is the number of terms, and D is the common difference. Like in AP, we always have these things, and sum of n terms will be given by n by 2 times A plus L, where L is the last term. When the last term and first terms are known, this is what we do, right? And when the last term is not known, then in that case, we'll use n by 2, here 2A plus n minus 1 times D. By the way, both these formulae are interchangeable, depends on whether we know the last term or not. So these three are most important things for AP. Let's do a few questions on AP and let's see till where we can go. Good evening, Manisha. This is the first question. It says sum of the first n terms of an AP is given by Sn is equal to 3n squared plus 2n. Find the 25th term of this series. All right. So the questions, the formulae are simple. All of you know that because mostly people have already walked through CAT. And so we won't be discussing much about the formulae. We'll just do the questions which are of moderate to difficult level. Okay, as we normally do. Hey, Floyd, good evening. Here is the first question that we have. And I'll use a timer also. The timer will be for 1 minute only. Yes, Manisha, that's right. जल्दी से करो. Okay. Okay, Shreyesh. 25th term will be S25 minus S24. Is that right? 25th term, fifth term, if you want to find, you just need to find S25 minus S24. So 3 into 25 square plus 2 into 25 minus 3 into 24 square minus 2 into 24 is what we need to find out, right? So you can do this really quick by taking 3 common here. 25 square minus 24 square is what we have. Like these are the few techniques to solve things quickly. 25 minus 24 is what we have. This can be, we can do it easily. Because a square minus b square is a plus b into a minus b. A minus b is 1 here. So 3 into 49 plus 2 into 1 is what we get. 147 plus 2 is 149. Option A. Cool. All of you got that. Next. Okay. So it says ratio of sum of the first n terms of two different APs is 7n plus 1 upon 4n plus 27. We need to find the ratio of their 11th terms. So basically we need to find, okay, so let's say the two APs are like that. In the first AP, the two APs, right? So AP1, let's say the first term is A1 and common difference is D1. And in AP2, the first term is, let's say, A2, common difference is D2, because we don't know whether the first terms they're equal or not, right? So sum is given by what? Sum is given by, as we know, n by 2 times 2a plus n minus 1 times b. So for the first AP, we will replace a with a1, b with d1. For second AP, we'll replace a with a2 and b with d2, right? So having said that, the ratio, if I try to put it here, so if I replace that n is common, so n by 2 will be cancelled out. We're left with 2a1 plus n minus 1 times d1 upon 2a2 plus n minus 1 times d2. This is what is known to us. Is that right? That is known to us. We need to find the ratio of 11th terms. By the way, what will be the 11th term? a1 plus 10d1 upon a2 plus 10d2. That is what we should get, isn't it? Let me do one thing. Let me divide numerator and denominator with 2. If I do that, what do I get? I'll get a1 plus n minus 1 by 2 times d1 upon a2 plus n minus 1 upon 2 times d2 is equal to 7n plus 1 upon 4n plus 27. So somehow I want this. I can get this here by replacing n minus 1 by 2 with 10. Is that right? The moment I do it, I'll get my answer. So if n minus 1 by 2 is 10, that means n will be equal to 21. Let's put 21 here and get the answer. So 7 into 21, 147 plus 1 is 148. 21 into 4 is 84. So 111 is what we get. क्या ये 37 से कट रहा है क्या? 37 3 सर, 37 4 सर कटता है? हाँ कटता है. 4 by 3 is the answer. Option C. What happened? Nobody gave me the answer. That's really strange. Did you guys get it? Let me open my camera first. Hi. Do you get this? What happened? I can see nobody has answered, isn't it? So basically, what we had and what we want to find out, we need to kind of make them same, isn't it? So how could I make it same? Here I saw it's 2, here it's only 1. So I divided by 2 in the numerator as well as denominator. Calculation error कर दिया था. ठीक है, चलो, let's go to next one. Here we have one more question. Okay, I will just start the timer. I think 1 minute थोड़ा सा less है. 1 minute 30 seconds कर देते हैं. That'll be a better idea. Yeah, what happened? 480 is what you get? Okay. Arthro. So if three numbers are in sum, the sum is 24, can I say the numbers are 8 minus d, 8 and 8 plus d? Do you understand that? This is the quickest way to solve this question because the three numbers in AP. So instead of taking them A plus D and A plus 2D, then dividing and doing all that stuff, if the sum is 24, obviously the average is 8. And what is the average? Always the middle term. Yes or no? Do you understand that? So middle term is the average. Middle term is 8. And if D is the common difference, the first term will be 8 minus D, third term will be 8 plus D. So now the sum of their squares is 200, right? So 8 minus D whole square plus 8 square plus 8 plus D whole square must be equal to 200, isn't it? Rest, I think you know what to do. 8 square पे यहाँ भेज दो 64. So I'll get 8 minus D whole square plus 8 plus D whole square is 200 minus 64. How much is that? 136, right? 136 is what we get. So I can either, expand 8 minus d whole square, 8 plus d whole square, form a quadratic equation, then try to solve it. Or I might use some kind of, familiar numbers, two perfect squares which add up to 136. Or do we have two such numbers? Yes, I think 100 plus 36 is there. So 36 plus 100 is a possibility, If that is the possibility, then 8 minus d must be 6, 8 plus d must be 10. Is that possible? Yes, that's possible if d is equal to 2. Wow. So we got the number 6 into 8 into 10 is the number. Answer is 480. Ha ha ha. Did you like it? So instead of expanding and making it quadratic equation and wasting a lot of time, I just did it by this. So if you use this way, you will take not more than 30 or 40 seconds. And I'm pretty sure only some people did it this way. Who did this way? Arithro or Avi, who got the answers? Did you do it this way? Or did you actually expand the equations? Yeah. Be quick, tell me. Nobody's saying anything. Okay, let's read it that way. Very good. Others, did you get it? हाँ वो कट जाएगा डी स्क्वायर हाँ श्रेयस मतलब एक्सपैंड करने पे वो जो क्वाड्रेटिक है वो डी स्क्वायर माइनस हो जाएगा दैट आई नो यस है ना ये बस इस तरह जो लोग कर रहे हैं बस उनको 100 + 36 दैट इज व्हाट वी नीड टू these are some familiar things which come up with a lot of practice. Akshat, you expanded. That is the first instinct that comes to mind. If there is a bracket and square, you try to expand it. Just try to do things like this. You'll be saving a lot of time in the real exam. Chalo, next. All right. Should I give you more time? TP is 1 by Q. TQ is 1 by P. You need to find the sum of first PQ terms. SPQ is what? Yeah, I can put in the, I can try to solve this, but something comes to my mind. I'll just try. I'm not really sure. What if I put P equal to 1 and Q equal to 2? In that case, T1, the first term will be 1 by 2, and TQ, the second term will be 1 by 1, 1, right? So first term is 1 by 2, second term is 1, and if it's an AP, common difference is equal to 1 by 2. So S of PQ, that means sum of 1 into 2 terms, that is sum of 2 terms only. 1 by 2 plus 1 gives me 3 by 2. How can I find 3 by 2? I can find 3 by 2 in which of the values? 0 nahi hai, 1 nahi hai. PQ plus 1. If I put P as 1 and Q as 2, 2 plus 1, 3 by 2, yeah, that's correct. 1 plus 2 is 3. 1 by 2, 1 into 2 minus 1 is 1. No. See, this is called the principle of mathematical induction. By using this, you can solve the question in just 20 seconds. How many of you did it this way? Arithro, I think he did it this way. मजा आ रहा है एक भी सवाल में फॉर्मूला लगा ही नहीं रहा मैं दिमाग में ऐसे ही आया बस चेक किया मैंने और वो हो गया मतलब इट्स नॉट दैट आई वाज थिंकिंग टू सॉल्व इट लाइक दिस ब्यूटीफुल राइट गॉट इट I'll wait for a few seconds and everybody will tell me did you understand Okay, Arithro, second time you did that. First time, first instinct was not this. Should I go slow? Hey, Vihan, you the same way? Very good, Vihan. I'm impressed. Guys, tell me something. There are 9 to 10 people watching. Tell me. Akshat, Faraz, Shriyesh, Manisha. Chalo, let's go to next one. Here we start. Speed is fine. Perfect. Okay, no was for am I going slow? Okay. Okay. A man starts repaying a loan as a first installment rupees 100. He increases the installment by rupees 5 every month. क्या सवाल है ये? What amount will he pay in the 30th installment? Seriously. T30. 100 first term plus 29 times 5. तभी सबने जल्दी जल्दी कर लिया है ना? क्या हो जाएगा ये? या कितना है ये? 145. 245 is what I'm getting. ये ऑप्शन है. ठीक. Coming to GP now. So nth term in a GP is given by what? A into r to the power n minus 1. Where A is the first term, r is the common ratio. Krishna, yeah, it's about to happen next week. Common ratio, right? And sum of n terms will be given by a times r to the power n minus 1 upon r minus 1 if r is greater than 1, and a times 1 minus r to the power n upon 1 minus r if r is less than 1. All of us know that. So of infinite GP is given by first term upon 1 minus common ratio, and here r will always be less than 1. It will always be a fraction. All right. Okay. That's all. Let's do the questions. Sum of infinite geometric series. Here we have a series. It says 5 plus 10 by 3 plus 20 by 9, and it's an infinite series. Try solving it. Here I think I'll give you 2 minutes. All right, let's check this out. Okay, so here what do I want? I need to do something. Let me open, okay, a whiteboard here. So the question was 5 plus 10 by 3 plus 20 by 9 and so on till infinity. So I can do one thing, I can assume x to be equal to 1 by 3. If I do that, the series becomes S is the sum of series. I'm writing S, denoting it with S. 5 plus 10x plus 20x square plus 25x cube plus 30x to the power 4 and so on till infinity, right? That is what we have. Now, if I multiply this thing with x, what do I get? 5 becomes 5x. Just for sake of no confusion, I'm writing 5x below 10x so that we can subtract it afterwards. This is 10x squared. This is 20x cube. This becomes 25x to the power 4. And now my life is really sorted. Why? Because if I subtract this, I'll get 1 minus x times s is equal to 5 plus 5x. ये क्या हुआ है? 10, 20, 5, then oh, that is not the case. Double हो रहा है. I'm so sorry. I made the wrong pattern. There's a wrong pattern that I made. Okay. Correct pattern is something else. It will be S is equal to 5 plus 10x plus 20x squared. So 5 twos are 10, 10 twos are 20. Right? That is what is happening. So 20 twos are 40, x cube. Then I'll have 40 twos are 80, x to the power 4, and so on till infinity. Right? Is that right? और ये इनफाइनाइट जीपीए, इससे तो एक चीज दिखाई दे रही है, अगर डबल हो रहा है नीचे बाय 3 हो रहा है तो फिर तो खत्म ही हो गया ना, कुछ करना ही नहीं यार, ये तो सिंपल हो गया, मैं इतना सोच ही क्यों रहा हूँ. इट्स बेसिकली द रेशियो इज 2 by 3, दैट्स इट. Because 5 into 2 by 3 is 10 by 3 into 2 by 3 is 5 upon 1 minus 2 by 3 is the answer. The answer is 15. I was thinking more. Okay, yeah. I think, okay, Avi and Arithro are saying the same thing. चलो, वो तो miscellaneous sequences में आएगा, GP है ना ये तो. Here we come to the next question. This one is easy. Third term. So if there are 5 terms, then third term will always be geometric mean, right? Geometric mean is given as 3. To find the product, what is geometric mean, by the way? There are 5 things, just multiply them, okay? And let's say product is P. So fifth root of it is what we need to find. What is the geometric mean? So 3 to the power 5 will be the value of product, which is 243. 3 की power 5 directly बोला हुआ है. 4 है यार, 3 नहीं, मैं क्यों ऐसा कर रहा हूँ. 4 की power 5 is the answer. We'll go for option B. I think all of you have done it right. Okay. The next one. Sum of first 3 terms of a GP is 16. Sum of next 3 terms is 128. What is the common ratio? first three terms of a GP. So let's say the first three terms are A plus AR plus AR square. By the way, I would have taken A by R, A and AR, but because we have next three terms also, so no need of taking that. This is given as 16, and the next three terms, that is AR cube plus AR to the power 4, AR to the power 5 is given as 128. What's the common ratio? Simple. I can just take things common, right? So if I divide, if I divide this by this, what do I get? If I divide, ऊपर से a पूरा कट जाएगा and we are left with 1 plus r square. नीचे I can take ar cube common. 1 plus r square is equal to 16 upon 128 is what I get, right? Is that right? So this and this get cancelled out, right? Yeah. 1 by r cube, 16 by 16 eights are 1 by 8. The value of r is 2 here. Go for option A. ऐसे सवाल आएंगे. Next. X, Y, Z, or in AP, that means y square must be equal to x times z because y will be the geometric mean, right? In a GP. And it's known that this is also known that a to the power x is equal to b to the power y is equal to c to the power z. Which of the following should be true? So let's say that this is equal to k. If I assume this to be equal to k, then I'll get what? I'll get something. ठीक है. So the value of a नहीं मुझे x चाहिए. ठीक है. Anyways, so I can say that the value of x in terms of log will be log k base a. The value of y will be log k base b, and the value of z will be log k base c. Yes or no? Can I say that? Let's put the value over here with these values. Y square is log k b इसका square is equal to log k base a into log k base c. That is what we have with us. What can we do now? Yeah. Is this clear to all of you? Is this thing clear? This is clear. Yes. ठीक है. I can use the change of base formula, right? That can be used. है ना? So I can write this as log k upon log b का whole square है ये, isn't it? And here I get the same thing, log k upon log a, log k upon log c. See what's happening? Log k बुरा कर चुका है, वैसे k constant था. So I'm getting 1 upon log. So log a, log b का square है. So log, I'll do one thing. See, I'll just cross multiply. Okay, log a को भेज दूंगा मैं लेफ्ट हैंड साइड में. I'll get log a upon log b, and एक log b को राइट में भेजा, log b upon log c is what I'm getting. So based on this, I can say log a base b must be equal to log b base c. A option is correct. Even b is correct. So we'll go for both a and b. Is that clear? Understood? नहीं, ऐसे ही बहुत टाइम नहीं लग रहा अरित्र, जो मैंने यहाँ पे किया है, that is okay. Is that clear, everyone? You won't take much time here. Yes or no? Cool? Clear? इमेज देख रहे हो, मंडाला बना हुआ है. नेक्स्ट. क्या सी भी करेक्ट था क्या? एक मिनट. सी क्या है? एक्स लॉग ए वाई लॉग बी. यार तो फिर तो क्या करें फिर इसमें अब? ठीक है, ऑप्शंस ही ऐसे हैं. ठीक है, चलो, लेट्स डू दिस वन. ए बी सी ऑल आर करेक्ट गाइस. ये होना चाहिए ए बी एंड सी. सो विल गो फॉर डी, राइट? चलो, दिस वन. All right. Sum of n terms is given as 255. Nth term is given as 128. Common ratio is given as 2. Find the first term. What happens? What happened? I can't see any people answering here. ये तो एक 2 की पावर्स का प्रॉपर्टी भी है. Do you remember that? So 1, 2, 4, 8, 16, ये सब 2 की powers हैं, right? 32, 64 and so on. I want to show you some pattern. 1 plus 2 is 3 and 4 is 1 more than 3. 1 plus 2 plus 4 is 7. 8 is 1 more than 7, isn't it? That always happens. राइट राइट। तो इसका मतलब ये हुआ थोड़ा और आगे बढ़ाऊं 128 then I'll get 256. So basically every number in 2 in the powers of 2 is basically one more than the sum of its preceding elements. तो यहाँ तक का सम 127 ही होगा, ये एक ज़्यादा है। तो यहाँ तक का सम 255 ही होगा, ये एक ज़्यादा है। So n terms is 255, nth term is 128. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 terms in totality, and the first term will be 1, not 2. Okay, Avi? See, this is a property of the powers of 2. In case you don't know it and you realize this today, just throw some likes. Okay? Why this happens? Because 2 to the power n minus 1, जहाँ कहीं भी होगा, है ना? Upon 2 minus 1, this is going to be the summation of powers of 2 till n minus 1 terms. Okay? This always happens. 3 वाले में ये ऐसा होता है, 3 की पावर n minus 1 नीचे 3 minus 1 हो जाता है 3 वाले में. I'll just show that to you in case you don't know. I'll just show that to you. See, in 3 what happens? 1, 3, 9, 27, 81. Okay, 1 plus 3 is 4. 9 is 2 times 4 plus 1. Similarly, 1 plus 3 plus 9 is 13. 27 is 2 times 13 plus 1. This always happens. तो कहाँ तक भी ले जाओगे? तो अगर उल्टा लेके जाओ तो 9 क्या है? What is 9? It's 2 into 1 plus 3 plus 1, or I can also say 1 plus 3 is 9 minus 1 upon 2. This is the value of 1 plus 3. Or simply saying 3 square minus 1 upon 3 minus 1 is basically equal to 3 to the power 0 plus 3 to the power 1. See this pattern? Yeah. So if I extend this pattern, I'll get 3 to the power n plus 1 minus 1 upon 3 minus 1 is equal to 3 to the power 0 plus 3 to the power 1 till 3 to the power n. Isn't it? See, I just showed you a pattern. तो टू में भी यही चलेगा, 3 में भी चलेगा, नीचे बस ये 2 minus 1 3 minus 1 चलता रहेगा. So if I generalize it even further, I'll get x to the power n plus 1 minus 1 upon x minus 1 is equal to x to the power 0 plus x to the power 1, all right, plus x square and so on till x to the power n. This always happens. Cool. That's going to help you a lot. 2 की पावर हो, 3 की पावर हो, 4 की पावर हो, 5 की पावर हो, कुछ भी हमेशा ऐसा होगा. Is that clear, guys? All right. All of you got that? Interesting stuff. Yeah? Understood? Interesting, huh? Now coming to miscellaneous sequence. All of you, tell me, is this understood? I can see people are very slow in writing here. Yes, Yesh. Miscellaneous sequences. Here we go. This is the first one. Find the some of the series. This 1 upon 1 into 2 plus 1 upon 2 into 3 till 1 upon n into n plus 1. I think you can just tell this mentally. Memorize? Why? Sunidhi, why to memorize? 2 का तो याद ही है, 3 का याद होगा, 4 का 2 से ही बनता है, और 5 का you can just you can 5 की पावर 5 तक सिंपल है. 5, 25, 125, 625 is what you already know. Just the 3, 1, 2, 5, you can just multiply it really quick. Okay. This is partial fractions. I think I told you this thing, right? देखो यहाँ पे क्या होगा, 1 upon 1 into 2 plus 1 upon 2 into 3 and so on till 1 upon n into n plus 1. Now, if I write 1 upon 1 minus 1 by 2, this is 1 by 2. If I write 1 by 2 minus 1 by 3, this is 5 by 6. There is some problem. तो ऐसा करें क्या? Sorry, this is 1 by 6 only, right? This always happens. It goes on happening till 1 by n minus 1 by n plus 1. So basically, every alternate term gets cancelled out. Not alternate, second से लेके second last तक. We are only left with 1 minus 1 upon n plus 1. That's all. So if you solve this, you'll get n plus 1 minus 1 upon n plus 1, which is nothing but n upon n plus 1. So the answer is n upon n plus 1. Do we have that option? Option B. Is that clear? This partial fractions, जितना गैप होगा, जैसे मान लो 1/1 × 3 होता, तो मैं क्या करता यहाँ पे इसको लिखता 1/1 minus 1/3 और बाहर 1/2 कॉमन निकाल लेता, where 2 is the gap. So whatever the gap is, you will take it common. So let's say we have 1/2 into 5. Gap is 3. This will be 1/3 times 1/2 minus 1/5. Simple. Or if I generalize it, I'll get 1 upon a. देखो 1 upon a times a plus k अगर दिया हुआ, this will always be equal to 1 by k times 1 by a minus 1 upon a plus k. This is generalization which comes to partial fractions. We've done this in CAT also, but you can just write this down as a micro hack. All right, these are known as telescopic series because only the first few terms remain, the first and last, sometimes the first two and last two. That is how it happens. Is that clear? Is that cool? All of you got that? Understood? Tell me, be quick. Interesting, huh? Let's do this one. This is an infinite series. Yes. Yes, 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 certainly. That is the reason they said mod x is less than 1. इसका मैंने एक शॉर्टकट बताया था बहुत पहले, बहुत पहले क्या, when I was teaching cat. preparing you for CAD. Do you remember that? So I told you 1 plus x square and so on to infinity is basically 1 minus x to the power minus 1. Do you remember that? And then I said, I proved, and I proved by using binomial theorem. Do you remember that? I said binomial theorem, what if the powers are minus 1? Do you remember that? So 1 minus x की power minus 2 जो था, वो यही था जो यहाँ पे लिखा हुआ है. B option. Do you remember that? Sunidhi, if you were not in that class, I'll just tell you 1 minus x की power minus 3 अगर होगा. So this is, the coefficients are 1 each. Here the coefficients are natural numbers. The coefficients are sum of natural numbers like 1, then 3, then 6, then 10. You get this value. What I'm saying here, see here the coefficients are 1. All coefficients are 1. That is starting of the natural numbers. It is beginning of natural numbers. Here the coefficients are natural numbers themselves. Here the coefficients are sum of natural numbers. Sum of first natural number is 1. Sum of two natural number is 1 plus 2, 3. Sum of three natural number is 1 plus 2 plus 3, 6. Sum of four natural number is 1 plus 2 plus 3 plus 4. That is 10. And I did this in a very fascinating manner, which I can do now also, but then we don't have much time. For now, you can just kind of, note this down, make a note of it. So if I say, what will be, now tell me something. 1 plus 4x plus 10x square plus 20x cube. If I ask you what will be generalization of this, can you tell me? Okay, Shreyesh, this will be equal to what? This is sum of natural numbers. Sum of natural numbers. Sum of one natural number. Sum of two natural numbers. So 1 plus 3 is 4. This 1 plus 3 plus 6 is 10. Do you see that? How beautifully it expands. You'll get 1 minus x to the power minus 4 always. Clear? Those who are not in that class, just note this down. I'll wait for 30 seconds. Note this down and then tell me note it. Shreyesh, it's called nothing. It was made by me only. In my Brahma Ganit, I devised this theorem. I don't think it's anywhere. Just watch my class. So I just did, I just used binomial theorem. You know what is binomial theorem, right? करवा दूं क्या? Bro, what is binomial theorem? X plus y raised to power n. I'll just write the binomial theorem here. N, C, R, sigma is there. R starts from 0 and ends at n. NCR, x to the power n minus r, y to the power r. The only thing that I did over here is I assumed x equal to 1 and y equal to x and n equal to minus 1. If you do that, you'll get 1 plus x to the power minus 1. All right? Yeah. So now you will get minus 1 C0. 1 की power कुछ भी हो और x की power 0 is what you get. Then you get minus 1 C1. Minus 1 C1. That will be x. Minus 1 C2. That will be x square. Right? Isn't it? Then minus 1 C3. X cube. Now you will be surprised that You have always heard that n is greater than or equal to r. Here I have taken it as 1, minus 1. So you might be kind of flabbergasted. That is the right term to see me doing this, but then that is how it is. Minus 1c0 will be 1, minus 1c1. So what is ncr, by the way? It is factorial n upon factorial r into factorial n minus r. We know that, right? So this will be minus 1 into minus 2 and so on till wherever it can go upon factorial 1 into minus 1 minus 2, factorial of minus 2. So this get cancelled out, we're left with minus 1 only. Is that right? So I'll get minus x. Shreyash, I'm doing it here. Minus 1 c2. So it'll be minus 1 into minus 2 into minus 3 and so on, right? Upon factorial 2 into minus 1 minus 2, that is factorial minus 3. See, this all gets cancelled out. So 2 से पूरा कट जाएगा, plus हो जाएगा. So basically what you will get here is, you get 1 minus x plus x square minus x cube and so on till infinity. Now, in the same thing, I took x equal to 1, y as x, n equal to minus 1. What if I take y as minus x? The moment I take y as minus x, then wherever I have a negative value, that becomes positive. Whenever we have an odd power, that becomes positive. And when I have an even power, that will be positive itself. So this is for 1 minus x ki power minus 1. Is that clear? Got it, Shriyesh? Seems interesting. थोड़ा जल्दी बता दिया मैंने. I'm assuming that you know binomial theorem and you have to get calculations. That is why it did not take much time, but I hope you have understood that, right? Looks good. I'll wait for 20 seconds so that Shriyesh and Sunidhi and everybody else who was not there gets it completely. Mhm. Got it? Good. You are smart. Here comes the next question. हो गया था नहीं? Yes. Consider the sequence. A1 is equal to 2. An plus 1 is equal to an plus 2n plus 1. Find the value of 8n. Yes. Newton. Sir Isaac Newton was the goat. The real goat is Sir Isaac Newton. People use it for different people, but Isaac Newton was the one who made binomial theorem. But you know what? Aditya, चलो बाद में भी बात करेंगे इस बारे में. There are certain things which, if you go totally inside mathematics, you will see new patterns which are yet to be found. Come on, tell me the answer. Yes, Arithro. There's a huge story on that. I think I told this story in one of my CAT classes. Probably you guys did not see me teaching CAT last year. मैंने पूरी कहानी बताई थी इसके ऊपर, न्यूटन एंड लिबनिट्ज के ऊपर, what exactly happened between them at that time. Well, Shriyesh says 101. How do you come to this conclusion? Did you actually try to find it out? So obviously you can just put and keep on putting the values n as 1, getting a2, and then doing all that stuff. Is there any other way which we can do here? मुझे लगता है कि मैं इस पे कुछ खेल सकता हूँ थोड़ा बहुत. I have a very strong feeling that I can play with this. Do you also get that feeling that you can play with this? मुझे लग रहा है कि 2 की पावर्स का खेल है यहाँ पे कुछ. वैसे 1 पुट करने से भी हो ही जाएगा. If you put 1 here, you'll get a2 is equal to a1 plus 2 into 1, that is 2 plus 1, you get 5. And if you try to put n as 2, you will get a2, that is 5 plus 2 into 2, 4 plus 1. You are getting 10. There is a game. Yes. Cool, Arithro. That's what. That is what I was looking at. It's a recursive function. So you get an plus 1 minus an is equal to 2n plus 1. This is what we get. Okay, Shriyesh. This is how we can play with this. वैसे यहाँ हमें दिखाई भी दे रहा है क्या हो रहा है. Are you getting it? What exactly is happening over here? You know what? This guy is 1 square plus 1. This guy is 2 square plus 1. This guy is 3 square plus 1. So basically an is n square plus 1. That is what you will get if you try to play with this. So a10 is 10 square plus 1. That is 101. So even if you don't know how to play with recursive functions, you at least can see the find the pattern. Okay. The moment you see the pattern, probably you'll see the pattern in three steps. If not, in the fourth step, you're going to find the pattern. So a4 will be a3, that is 10, plus 2 times 3, that is 6, plus 1, you get 17. Now you see the pattern 4 square plus 1. जिन लोगों को बहुत ज़्यादा मैथ्स नहीं आती, कोई बात नहीं, लॉजिकली भी कर सकते हैं. And that is the reason this question can come in MBA entrance, because even if you don't know pure mathematics, at least you see the logic. So what I try to always tell in my classes that pure mathematics, in fact, mathematics is study of patterns. I think that is the reason why pure mathematics was developed in the first instance. Got it? Okay. Did you understand? And if you want to see the recursive function, do you want to see that? Let me show that to you as well. Pure maths में कैसे solve हो रहा है? देखो, an plus 1 minus an is equal to 2n plus 1. Tell me something. What if I let n is equal to n plus 1? Basically, I'm replacing n with n plus 1. If that is the case, I'll get an plus 2 minus an plus 1 to be equal to 2 times n plus 1 plus 1. That is how you play with recursive functions. See, अभी समझ में आ जाएगा, देखना अभी क्या होगा. This will be 2n plus 3. Getting it? All right. And if you do it once more, an plus 3 minus an plus 2. So here replacing n with n plus 2. Okay. So 2 times n plus 2 plus 1 is what you get. That is 2n plus 5. Isn't it? That is how you get the functions. So मैं एक pattern दिखाता हूँ. If this is the first equation, this is the second equation, this is the third equation. Now, if I add 1, 2, and 3, what exactly happens? If I add 1, 2, and 3, an plus 1, यहाँ minus an है, ये minus ये और ये cancel out हो जाएंगे, ये और कहाँ गया, ये cancel out हो जाएंगे, बचेगा सिर्फ ये और ये. So a n plus 3 minus an will be equal to sum of all of it. So 2n 3 बार आ गया और 1 plus 3 plus 5 आ गया, which is nothing but n square. 1 plus 3 plus 5 is sum of odd terms, odd numbers. So if we have n odd numbers, we say 3 square है यहाँ पे, right? Is that clear? Because we are dealing with three odd numbers. Did you understand this? बात समझ में आ रही है? That is always going to happen. Yeah, yeah. A1 was 2. We know A1 is 2. We already know that. So अगर मैं इसको पूरा expand कर दूंगा तो I'll get it right. Okay, cool. You got it. The recursive functions coming to next number. Next question. Sum of two-digit natural numbers which leave remainder 1 when divided by 3 is. ये तो सिंपल सवाल है, फटाफट कर दो इसको. 3n plus 1 का समेशन करना है. Because 3 sigma n plus sigma 1 is equal to 3 times n into n plus 1 by 2 plus n. Two-digit natural numbers. तो n की वैल्यू कम से कम 3 होगी, राइट? n will be 3 to कहाँ तक जाएगा? 3 3s are 9 plus 1 is 10. 3 33s are 32 तक जाएगा, 32. 3 to 32. So you'll put 32 over here and then you'll put n 2 over here and then subtract. Okay? समझ में आ गया? So n as 32, whatever you get, then put n as 2 and then subtract, you get the answer. All right? Understood? That is one way of doing it, but we can make it even simpler. Just for the people who do not know pure mathematics, उनके लिए काफी आसान है. पहला नंबर है 10, आखिरी नंबर है 96. कितने नंबर टोटल है यहाँ पे? 3 से 32. कितने नंबर है ये? ओवरऑल 30 numbers are there. So first term plus last term, and it's an AP. 30 terms, 30 upon 2, n by 2 into a plus l is the simplest way to solve the same question. Is that clear? Understood? Is that fine? नाइन्टी सेवन लास्ट टर्म है, हाँ ठीक है, 97 कर लो. ओके. 107 into 15. 15. 1605 will be the answer. Option A. This is also good. This is better, in fact, because this saves time. All right. Okay. The last one for the day. We did 20 questions, 15 questions in such a short duration of time. 1605. हाँ, ठीक है. Okay. ओहो, ये कोई सवाल है. A plus B plus C is 18. Sum is constant. So product is maximized when the numbers are as close as possible. Let all of them be 6 each. 6 into 6 into 6, 260 is the answer. That's all, guys. Done for the day. वैसे देखा जाए ना, ये 15 सवाल जो है, इसमें 3 4 सवाल छोड़ के बाकी सवाल काफ़ी सही लेवल के थे, और इसको हमने 1 घंटे 12 मिनट में ख़त्म कर दिया. So now I think at least you guys who are constantly, continuously watching the sessions, you guys have come at a level where I can do 30 questions, 50 questions in I think 3 hours. यही करेंगे, जल्दी से कोर्स खत्म करेंगे. Within 5 to 6 days after that, there will be huge marathons of 6 hours each. Okay. Today I was discussing this with Arithro, and now let's discuss with all of you. What I'm planning is, see, the thing is, ZAD is near, so the plan sometimes changes in between. What I'm thinking that what if I do one huge session of last 7 to 8 years of PYQs, not the entire PYQ. It's like total वो वाला क्या बोलते हैं, वो कल का क्वेश्चन सपने में आके डराया श्रीकेश. ओके, रिवाइज कर दूं. डाउट, अच्छा सीरीज वाला, ठीक है वो भी कर देता हूँ। तो मैं क्या था कि एक पूरा अरिथमेटिक, एक पूरा अलजेब्रा, एक पूरा ज्योमेट्री भी, ज्योमेट्री इज वेरी इंपॉर्टेंट इन ज़ैट, इट वाज नॉट इन कैट, तो ज्योमेट्री बहुत फोकस करना है। देन पीएनसी नंबर्स का एक 4 सेशन ये हो गए, डीआई का एक पूरा, बिकॉज इन एक साल में 2 से 3 डीआई सेट्स आते हैं, और उसमें 3 3 सवाल ही होते हैं आई थिंक, है ना। तो हम एक ही सेशन में पूरा कर सकते हैं डीआई, कंप्लीट डीआई, वन कंप्लीट सेशन ऑफ डिसीजन मेकिंग, एंड 6 हो गए, एक पूरा कर लेंगे वीए और एक आरसी, ऐसे करके इवन इन 8 marathons of 6 hours each, I think we can finish off with the entire PYQs, and also I will keep on telling any micro hacks that are required. सुनिधि 8 days का अगर है तो मैं सोच रहा हूँ कि आज क्या डेट है, टुडे इज 20th, ओके, 19th. So you know what, I am upgrading my studio, I am putting a big screen over here which will be arriving probably in 2 to 3 days, लेट्स से 5 days मान लेते हैं। तो 24th से अगर हम शुरू करते हैं तो वी कैन डू इट इन 8 सेशन में, ज़्यादा बोल रहा हूँ, एट मैक्स इन 6 सेशंस इट विल बी डन। सो विल स्टार्ट विथ ऑन 24th आई थिंक, 24th just before Christmas, and finish it up before 3rd. All right, and that will be I think more than sufficient. All right, so let's prepare for that. Getting 11 12 in DM in 30 minutes, that's great. The strategy is fine. Yes, 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 yes. Yeah, you're right. Spending more time in DM will not make a big impact. That's right. Deepak Kohli, I got it. No, Deepak, this is grad school channel, bro. Okay, I was working with them till last month. Probably that is why you might be confused. This is grad school. Welcome to grad school. Okay, we'll do that. अच्छा, रित्रो कुछ रिवाइज करने को बोल रहा था, लेट अस रिवाइज दैट, ऑल ऑफ यू। देखो, एक बार की बात है। अच्छा, आई थिंक लॉट ऑफ यू नो दैट आई एम प्रैक्टिसिंग मैथमेटिशियन, सो आई हैव क्या कहते हैं, क्या कहते हैं उसको, हाँ, तो वंस आई वाज प्लेइंग विद functions, I'll show you something. So I took functions, मैं बहुत confused था. I'll tell you. So it's like let's say f, a function, there's a function fx, and that function is equal to c, where c is the constant, c is the constant. Okay, so if domain is, if I put x equal to 1 or 2 or 3 or 4 and so on, the range will always be c. Is that right? Let me say, let me take, in place of c, let me take 1, to make it better sounding, let me take 1. So what exactly happens here? It's 1 1 1 and so on, right? So basically I'm dealing with, there is a poly, okay, रुको थोड़ा सा और इसे properly बताता हूँ मैं. There's a polynomial, it looks like this: a0 x to the power 0, a1 x to the power 1, a2 x to the power 2, right? a3 x to the power 3 and so on. Do you know what is a polynomial, by the way? An x to the power n. What's a polynomial? A polynomial looks like this, in which um, n, you know, n will always be a whole number. Now, you need to understand that n is a whole number, and n is known as the degree of the polynomial. It's the degree of the polynomial. Okay, thanks, Deepak. Do you understand that? So some people, I have seen some people, they are like, okay, tell me what is the degree of minus x to power minus 1. People say minus 1. You know what? That goes against the entire notion of being a polynomial. या x की पावर 1/x² का डिग्री क्या, लोग बोलते हैं -2 है यार, ये गलत है. You know what? Degree exists only for polynomial, and a polynomial by definition is something where degree is always a whole number. It can never be fractional, it can never be negative number. Yeah, do you understand this? First of all, tell me yes or no. Is that clear? That is one thing. So now, what if I just take the constant term, पहले ये सब समझ में आ गया सबको? सिर्फ पहला ले लूंगा मैं, तो ये 1 हो जाएगा. a0 x to power 0 is 1, fx equal to 1. So if I put x as 1 2 3 4, keep on putting it, the range will always be 1. It won't change, right? What if I take the simplest polynomial of degree 2, which will be x square. If I put x as 1, x as 2, then 3, then 4, and so on, I'll get 1, 4, 9, 16, and so on, right? Isn't it? If I take the simplest cubic polynomial, x cube, I'll get 1, 8, 27, 64, and so on. Obviously, I can have x squared plus 3x and all that stuff can be there, but I'm just taking the simplest possible polynomial of different degrees. अब वो 2x² plus 3x plus 5 कुछ भी कर सकते हैं, but x², the highest degree is, highest power is 2. Okay, so now I was just playing along with it. So if I took the first one, the constant function, I saw that I have common differences in the zeroth step. So I'm calling d0 as the common difference in the zeroth step. When I took the simplest degree 2 polynomial, what I could see, I saw the differences as 3, then I had 5, then I had 7, then I had 9, and so on. And I kept on doing it until I could do. So I saw something. I saw, oh wow, what just happened? At the second step, D2, I got constant values. Similarly, if I took, fx equal to x, the linear function, I got 1, 2, 3, 4, and so on. The linear function, right? The simplest linear function. So I saw that at the first step only, I got the common differences. Now, what is important here in the zeroth degree function, at the zeroth step only, I got common differences. In the first degree functions, first degree polynomials, I got the constant difference in the first step, and in the second degree function I got the constant differences in the second step. Similarly, if I took the cube ones, 1, 8, 27, 64, 125, and Shriyesh, are you listening? I was playing with it. I saw 7, then 19, then I this 37, then it's 61, this is 12, this is 18, this is 24. I kept on doing it, so all my thoughts were correct. I got the common difference third step. So that means the differences, the common differences will be occurring in a step which is equal to the degree of the polynomial. And not just that, the most fascinating part is you will be surprised, you'll be happy to know that, you'll be fascinated. The most surprising part is these differences were actually factorials. This is factorial 0. This is factorial 1. This is factorial 2. This is factorial 3. Wow. So factorial 0 is equal to 1 by convention बचपन में पढ़ा दिया गया था, but you know what, when I found this I was like, it was bliss for me. I felt blissful. I felt, kind of blessed by God that I could understand that why factorial 0 is equal to 1. Okay, I will do more and I'll stop at the point where it starts making sense for MBA entrance, because the moment I cross that boundary, I'll be switching into pure mathematics. That will be PhD level maths. I would not go there. I'll stop when MBA entrance ka logic gets stopped. Okay, this is clear to you? Now, if that's the case, so I try to play with more functions. What if I say take fx is equal to 2x square? So what would ideally happen? Nothing would happen. The same thing will be there. इसका double हो जाएगा, तो d2 जो हो जाएगा 2 की जगह 4 आ जाएगा, isn't it? So that means if the function is like this, fx equal to ax square, then d2 will be a times factorial 2. Is that right? Do you understand that? See, if I take fx equal to 2x square, तो कैसा रहेगा ये? 1, 8, 18, है ना, 4 square 16, 32, 50। और अगर मैं करना शुरू कर दूं फिर से वही चीज, 7, 10, 14, एंड दिस इज 18। क्या है ये? कुछ यहाँ पे गड़बड़ हुआ है। ये 2 है, 6, 10, so I am getting 4. you know, where I was getting 2, I'm getting 4. Why this 4 is there? Because everything got multiplied with 2. So essentially, what happens, the common difference I'm getting at the second step only, second difference is common because it's a second degree polynomial. But whatever I'm getting is a multiple of factorial 2. Which multiple of factorial 2? Eighth multiple of factorial 2. What is A? Is the coefficient of the power of x, the highest power of x. All right. Is that clear, everyone? अच्छा, अब ये अगर खेल लिया तो एक बात बताओ, 2x² के आगे अगर मान लो मैं 3 लगा देता तो क्या फर्क पड़ता? कुछ फर्क पड़ता क्या? कोई फर्क नहीं पड़ता, तब भी एंड में मुझे 4 ही मिलता। इफ यू वांट टू सी, you can also imagine that, but let's see that 2x² plus 3, if I put x as 1, I'll get 4 plus 3 7. If I put x as 2, I'll get 11, I'll get 21, I'll get 35, I'll get 53. If I do it Bro, I'm getting the same thing again. ये 2 था भाई. 2 plus 3 is 5. Okay. I'm getting 6, 10, 14, 18. Yeah, I'm getting 4 again. So what exactly, why is it happening? Because this plus 3 is common to all the values. The moment it's subtracted, 3 gets cancelled out. So it doesn't really matter what is occurring after 2x square. So all that matters is, in any quadratic function, all that matters is a, nothing else. So d2 will always be 8th multiple of factorial 2. Do you agree? Is that clear? The rest everything will be cancelled out. Yes or no? यहाँ तुम प्लस 3x लगा तब भी वही हो जाएगा, क्योंकि वो 3x जो कॉमन है कैंसिल आउट होता जाएगा, चला जाएगा. So I'll take a pause for 20 seconds, absorb the information and tell me, is that clear? Is that right? That is right. Yes or no? So now comes what Arithra was asking. What if there's a series given to me and the series looks like this? Let's look at the series. All of you look at the series. The series looks like this. 1, let's say here I got 3, then I got 6, then I got 10, then I got 15, then I got 21, and so on. So I want to find out the general term of this series. What I'll do, I'll try to find the common differences. हाँ श्रेष, 2, 3, 4, 5, 6 कॉमन डिफरेंस आया कि नहीं आया? फिर से करा मैंने, अब कॉमन डिफरेंस आ गया. Now so I got the common difference in the second step. That means this is for sure a second degree polynomial. Do you understand? And if it's a second degree polynomial, it must be n के फॉर्म में लिखना, x के फॉर्म में नहीं. fn will be equal to an square plus bn plus c. That is something which we understand, isn't it? Okay, Deepak. Okay. So now we have established one thing, that this will always be a multiple of a. कौन सा multiple of a? d2 should be a times factorial 2, but here d2 is 1. That means a is 1 by 2. तो इसका मतलब ये a 1 by 2 है. तो fn जो है वो 1 by 2 n square plus bn plus c है. वाह, मजा ही आ गया देख के, है ना? a is 1 by 2, Deepak. Okay, a is not 1. A will always be factorial 2th multiple of d2. Clear? So once I have obtained that, now tell me something. If I want to find the range of this function, let's forget this because we have obtained the value. I want to find the value of b and c. If I want to find the range of this function, then what kind of range would it be? The range will be same as this series. This was the range of the entire function. गायब ही हो गया, क्या था यार ये? 1, 3, 6, 10, 15, 20. This is the range of the entire function. The moment I eliminate an square from there, basically I'm eliminating 1 by 2 n square from there. So if I put n as 1, I get 1 by 2, isn't it? If I put n as 2, I get 2. If I put n as 3, I get 9 by 2. Yes or no? That's what I'm getting. Yeah. Yes, now it seems easy. If I put n as 4, I get 8 here. So basically, if I want to find the range of this function, it will be the same range minus these guys. So 1 minus 1 by 2 is 1 by 2 only. 3 minus 2 is 1. 6 minus 9 by 2 is 3 by 2. 10 minus 8 is 2, and so on. So now whatever I have is the range of this function, and this function is a linear function in itself. See, you get the common term in the first difference itself. जैसे मालूम पड़ गया तो b का वैल्यू 1 by 2 ही है. So now the new function that I have is a is 1 by 2, b is also 1 by 2, and what is c now? So to find the range which is of c, it's a constant function. तो मुझे इस सीरीज में से 1 by 2 times n minus करना होगा. So if I put n as 1, I get 1 by 2. If I put n as 2, I get 1. If I put n as 3, I get 3 by 2. 1 by 2 minus 1 by 2 is 0. I get 0 everywhere. So that means c is 0. In the first d0 only I got the value. Here I got the value in d1 of b. I got the value of d0 in the 0th step itself. C is 0. So this function was essentially, fn was n square by 2 plus n by 2. That was the function. Or simply saying n by 2 common le lo, n plus 1. This was sum of sum of natural numbers. Why do I original function 1, 3, 6, 10, isn't it? 1 is sum of first natural number, 3 is sum of 1 plus 2, 6 was 1 plus 2 plus 3, 10 was 1 plus 2 plus 3 plus 4, and so on. So this process was extensively and exclusively, I'm flexing here actually, developed by me, um, I think 10 years ago. And ब्रह्म गणित जो मैंने एक बुक लिखा है उसके अंदर 9 theorems है, out of which one is this theorem. And this, the moment I say one more word, I'll go into calculus. So calculus is something I have developed my own calculus, which I'm writing now. That'll be Brahma Ganit version 2.0. So if anyone is kind of a mathematics enthusiast, probably after that exam, just connect with me. We'll discuss things. What if there is a cult called Mathematica or a religion called Mathematica? Let's see. चल तुम्हारा Z खत्म हो जाए MBA कर लो. कुछ बड़ा है purpose. Humanity, humans should have a purpose of creation. You know, the purpose is not reproduction, falling in love, getting married. No, that is okay. That is just the function of culture. The function of humans is to create something. बहुत टाइम से मैंने वो किया नहीं है मैं, लेकिन अब करूंगा. थोड़ा सा ब्रेक मिलेगा तो आई विल डेवलप माय कैलकुलस प्रॉपरली. हाँ दीपक, ब्रह्म गणित इज अ बुक रिटन बाय मी. ऑलराइट देन, सो दैट्स ऑल. अच्छा, इसी चीज को पहले भी लोग करते थे, और पहले कैसे करते थे बता दूं मैं तुम्हें, तुम सबने किया होगा. उसमें तुम कहते थे कि ये ए एन स्क्वायर प्लस बी एन प्लस सी है, एंड देर आर थ्री अननोन्स, राइट? थ्री अननोन्स आर देयर, सो यू नीड थ्री इक्वेशंस. तो उसमें तुम क्या करते थे, एफ वन रखते थे तो वो ए प्लस बी प्लस सी था, और एफ वन की वैल्यू वन थी. फिर तुम एफ टू निकालते थे जो कि फोर ए प्लस टू बी प्लस सी था, उसकी वैल्यू थ्री थी. तीन इक्वेशन मिलती थी, नाइन ए प्लस थ्री बी प्लस सी. देन यू सॉल्व फॉर ए बी एंड सी. दिस विल टेक यू 3 to 5 minutes depending on your speed, but this, if you practice it completely, this will not take you more than 30 seconds. And I think those people who have practiced it, I think Arithro has practiced many a time, it doesn't take more than 30 seconds, Arithro, right? Deepak, that book is not out in the market yet, क्योंकि उसका पीयर रिव्यू प्रोसेस चल रहा है. आई थिंक अप्रैल में वो बाहर आ जाएगी बुक. इट इज जस्ट 9 theorems. इट्स अ थिक कलेक्टर्स एडिशन. इट्स नॉट ओपन फॉर पब्लिक राइट नाउ. अप्रैल में आ जाएगा. ओके, ऑल राइट देन. ठीक है श्रेयस, पीएमसी प्रोबेबिलिटी का भी एक क्लास कर लेंगे. ठीक है, चलो. सो ऑल ऑफ यू हैव नोटेड दिस डाउन. अंडरस्टूड एवरीवन? यस अरिथ्रो. मुझे लगता है कि मैंने पढ़ाया तो बहुत लोग को है, बट अरिथ्रो इज द ओनली वन who has been practicing it. Those who practice it would be able to know that this is going to be really helpful and very fast. विंटर इज कमिंग. और हाँ श्रेयस, तुम बोल रहे थे एक बार खुद वैल्यूज डालूंगा, समझ में आएगा. बिल्कुल करना. देखो ये तुमने पढ़ तो लिया है, लेकिन मैं चाहता हूँ कि एक बार तुम लोग खुद मल्टीपल फंक्शंस लेके वैल्यूज पूरा देखो, एंड यू विल फाइंड दिस. ओके, बाय द वे फैक्टोरियल 0 is equal to 1. That is the most fascinating part of it. Bye bye everyone, take care. Yeah, Deepak.